If you wanted a 12-second summary of what mechanical engineers do, think Tony Stark building an arc reactor in a cave with a box of scraps. Okay, it's a movie, but think of all the different challenges to build this suit. Types of materials, power sources, durability, manufacturing, flight propulsion, and even the biomedical aspects. The reason I mention the suit is because it covers a lot of the 7 core industries that mechanical engineers work in. First up is aerospace. The idea that a mechanical engineer can draw up some rough drawings on a scrap bit of paper that will one day end up being a 254-ton machine that carries 300 passengers from London to New York, 35,000 feet in the sky, is simply incredible. Okay, great. But what exactly are mechanical engineers doing here? Well, it could be things like more efficient engines and reducing emissions. And you might be thinking, Henna, why always with the emissions? Well, besides from the fact that we only have one planet, efficiency means lower fuel costs, faster travel times, and this means getting to our destination quicker. Next up is manufacturing. Take Coca-Cola. 1.9 billion drinks are consumed a day. Mechanical engineers get in on that action. But what about the printers, light bulbs, laptops, screwdrivers, dishwashers, trash compactors, drain covers, office chairs, mechanical keyboards, camera lenses, zippers on jackets? Mechanical engineers deal with all of this in some capacity, whether it's the design, the manufacturing, or continuous improvement, they've got involvement. Moving on to power. We humans need so much energy, so it's figuring out the best type of energy for us in any given location. Let's say we live near a lake. Could we use hydroelectric batteries? Or something as wild as setting up an electricity grid to allow us to obtain long-distance electricity like some of the Scandinavian countries, where a lot of energy there is renewable. Next is the automotive industry. Cars once started with just a pair of wooden logs, so very basic. And now we have luxury Rolls Royces that are nothing short of pure mastery in the world of engineering. And it goes beyond this. Think F1 cars. How is it that a V6 1.6 litre engine in an F1 car produces over 1,000 brake horsepower, whilst the Rolls I mentioned with a beastly 6.75 litre V12 engine produces just 563 brake horsepower? Sure, there's turbos and superchargers and fuel differences, but this difference is really why mechanical engineers are so good at what they do. They meet specifications as perfectly as they can. Sure, mechanical engineers make our lives better by giving us supercars, bullet trains, and energy-efficient washing machines. But what about our actual lives? Well, that's biomedical engineering. Sure, a mechanical engineer can make artificial hearts or a kidney, but how do our organic bodies accept them? There's no USB-C connector here. Instead, they work closely with those in medicine and biomedical engineering to figure out how everything works together to really increase our lifespan. And this goes way past this. Think robotical surgery. Yes, you heard me right. Someone sitting in London undertaking an operation on a patient in America using robots. You can bet there's no lag there. What about railway? On one side, you have designed the incredible underground systems in densely populated cities like London, New York, and Tokyo, or railways like the bullet train, and eventually the HS2. But let's go really wild here. Think the transatlantic tunnel. Now, whilst it's completely theoretical, it'd be a train that travels from London to New York City at 5,000 miles per hour in just 54 minutes. Yes, you heard that right. You'd have tunnels deep underwater tethered to the seabed in a pure vacuum. Well, why a vacuum? Well, with there being a pure vacuum, air resistance is no longer a problem. Imagine having breakfast overlooking the Empire State Building, shopping in the West End, and then having dinner in Paris on top of the Eiffel Tower. It's a crazy thought that goes way beyond our current limitations in science and engineering. But this is the world that mechanical engineers live in, thinking of the unthinkable to take humanity to brand new heights. Now we move over to buildings and structures, but not in the way that civil engineers work their magic. This is more heating, cooling and ventilation, or what engineers call thermodynamics. Think about the systems you would need in a pharmaceutical factory creating drugs. Or what about the most economical and efficient way to heat a building, where there's plenty of access to geothermal energy? That's all part of thermodynamics. I've touched on the 7 core industries, but I'm not finished yet. We've got things like marine engineering, material engineering, weapons manufacturing, acoustic engineering, and so much more. And whilst they kind of fit into mechanical engineering, really, they deserve their own video. So don't worry, we haven't forgotten about them. We've barely touched the tip of the iceberg here. There's so much more to come.